Hello students, this is Mr. Ezra. Today we are going to talk about a way to divide polynomials called synthetic division. So before we get into synthetic division, let's kind of review what we've learned about polynomial division so far. We've learned that there was this algorithm or this process that we learned in like third, fourth grade maybe even a little earlier for some of us, where we divided and then multiplied and then subtracted and brought down the next term, and we repeated that process over and over again. And it's not that it's hard to do necessarily, but it's a lot of multiplying and subtracting and dividing, and and it takes some time, it takes some space, really. I mean, probably one problem could take up a fourth of your notebook paper if you're writing large. So we want a process that's a little more streamlined, and we have a process. There is another way to divide, and it is called synthetic division. Now, synthetic division is a process that we use to divide when the divisor is a linear binomial. So you have to be dividing by something that is linear with two terms, like x plus 2, or even 2x minus 3. As long as we're dividing by a linear binomial, then we can use synthetic division fairly simply, fairly easily. That's when it really is the right thing to use for division. So let's look at an example to see how this process works. We're going to use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. As we begin this problem, we got to talk about how we set up synthetic division. So first off, when we are dividing by x plus 3, that is the factor that we're dividing by, or the divisor. In synthetic division, we have to set that equal to 0 and solve. So we're going to subtract 3 on both sides. And synthetically, we're not going to divide by x plus 3. We're going to divide by the solution to x plus 3 equals 0, which is negative 3. So I'm going to give myself a little backwards L over here, and I'm going to put negative 3 in that L. Next, we're going to look at this guy right here, what we're dividing into, and we're going to look at all the coefficients. Now, in the last video with long division, I talked about something that I call the countdown, and that is making sure that all of your exponents are represented from the highest one all the way down to the constant. Well, here we have x to the fourth, but we're missing an x to the third term. So we're still going to have to use a placeholder for that missing term. It's going to go between x to the fourth and negative 10x squared. So now we have 4, 3, 2, 1, 0. We've got all of them accounted for using a placeholder for the x to the third term. So coefficients. If there's not a number in front of it, it's an understood 1. If it's missing, we use 0. Minus 10 is a coefficient of negative 10. Minus 2 is a coefficient of negative 2. And the constant is the last number that you want to represent. We're going to draw a line under here from left to right. And here is our procedure. Okay. We bring the first one down. You bring the first one down, bring one down. Then we multiply. Negative 3 times 1 is negative 3. Then we add down. 0 plus negative 3, or 0 minus 3, is negative 3. Then we multiply. Negative 3 times negative 3 is positive 9. Then we add down. Negative 10 plus 9 is negative 1. Then we multiply. Negative 3 times negative 1 is positive 3. We add down. Negative 2 plus 3 is positive 1. Multiply. Negative 3 times 1 is negative 3. And then we add down. 4 plus negative 3, or 4 minus 3, is positive 1. Now, on this last number here, we're going to put a little dividing L right there. Okay, let's kind of outline what we did again. We first brought down the first number. So we bring down first number. After we bring down the first number, we multiply. And that multiplication is going to happen where we're going to say -3 times 1. And that gives us this number here, -3. -3 times 1 is -3. After we multiply, we add down. So the first step was to multiply, or the second step was to multiply. And now we add down. 0 plus -3 is -3. And then we're going to repeat steps 2 and 3 until we get to the end. Again, -3 times -3 is +9, add down. -3 times -1 is +3, add down. -3 times 1 is -3, add down. All right, so that's the process. It's multiplying the number on the left by the bottom to get this part, adding, and then repeating that process over and over again. Once you get used to that, this process is awesome. It takes up 3 lines on our paper instead of long division, which took a whole bunch more. Now we need to talk about how to represent the answer, okay? These are all numbers, and our answer is a polynomial, okay? When we divide x to the 4th by an x, the degree of our answer is going to be 1 less than the degree we started with. So instead, this part of our answer is not going to start at x to the 4th, it's going to start at x to the 3rd. It's going to be 1 less than the degree. So that's 1 x to the 3rd minus 3 x squared minus 1 x plus 1. So 1x to the 3rd minus 3x squared minus 1x plus 1. Notice that my exponent gets smaller and smaller and smaller. And this guy right here is our remainder. And you might remember from before what we do with the remainder is we put it in the numerator. And in the denominator, we put what we were dividing by. Now remember, synthetically, we were dividing by -3. But the actual division, we're dividing by x plus 3. So that's what goes in the denominator of our remainder part, 1 over x plus 3. And this is our final answer. We can clean it up a little bit. It's not necessary to have a 1 in front of a variable. So more concisely, x to the 3rd minus 3x squared minus x plus 1 over x plus 3. This is synthetic division. This is using synthetic division to divide a polynomial by another polynomial. Okay, we got to get used to the steps. Bring the first one down, multiply, add, multiply, add, multiply until you get to the end. The last one's your remainder. And then we've got to get used to how to interpret this as our final answer. Let's look at a few more examples of how to use synthetic division to divide. So here we're going to divide 2x to the 4th minus x to the 3rd plus 4 by x plus 1. Remember that we're actually not dividing by synthetically, we're not dividing by x plus 1. Instead, we're dividing by the value for x when x plus 1 equals 0. So if I subtract 1 on both sides, I get x equals -1. I'm going to divide by -1. I put that on the left with a little kind of backwards L here to separate it. I'm then going to put my coefficients inside, starting with 2. Coefficients are numbers in front of variables. 2x to the 4th minus 1x to the 3rd, so it's going to be a -1. I'm missing the x squared, and I'm missing the x term. Since they're both missing, remember we have to have placeholders in for their place. Even though there's nothing there, we still use those placeholders. So we got 4, 3, 2, 1, and then our constant term always goes last. Give yourself a little space and draw a line. You might go ahead also and separate out the remainder over here. Go ahead and give yourself an L so that you know that's your remainder. And then we have to get used to this new process, this new way to do it. Bring down the 2, multiply -1 times 2, and that number comes up here to be -2. We add down -1 plus -2 is -3. We multiply -1 times -3 is +3. Add 0 plus 3 is +3. Again, multiply -1 times +3 is -3. Add 0 minus 3 is -3. Multiply -1 times -3 is +3. And finally, add one last time. 4 plus 3 is 7. When we're writing our answer, the resulting polynomial is going to have a degree that is 1 less than the one we started with. So since we started with an x to the 4th, this is going to be an x to the 3rd power. So we'll say 2x to the 3rd. Minus 3 goes next. That's x squared. Then plus 3, x, and then minus 3. And you should notice that starting at 1 less, you have a countdown of exponents, 3, 2, 1, and then the constant. The last part is our remainder. So it's positive, so plus 7 over. And whatever we were dividing by, whatever was going into our polynomial, that goes in the denominator, just like it did with long division. And that is our final answer for this division problem. Hopefully you're starting to kind of get used to the process and you're seeing, oh, I can do that. It's bring down, multiply, add, multiply, add, multiply, add, multiply, add, all the way to the end. You have to be careful. It's easy to make a mistake when you're repeatedly multiplying and adding. It's easy to do something incorrectly. But just go slow, take it easy, and try not to make any mistakes. We have another example here. I'll start with my countdown of exponents to make sure I don't need any placeholders. I've got 3, 2, 1, constant term, which is an x to the 0. So I'm good. I don't need any placeholders for this problem. I'm going to divide by not x minus 1, but the solution to x minus 1 equals 0, which is positive 1. So off to the left, I'm going to put a little L, and I'm going to divide by 1 synthetically. I use all my coefficients inside of my synthetic division. The first coefficient is a 1, the leading coefficient is a 1. -3 is next, then +8, and the constant is -5. Draw my line underneath here, giving myself a little space under there. Go ahead and set apart with another L the remainder. And then we do this process. Bring down the first number, multiply, goes here, add, goes here, multiply, goes here, add, goes here, multiply, goes here, and add one more time. Our degree of our resulting polynomial is going to be 1 less than x to the 3rd, so this is going to end up being 1x to the 2nd power, which is just x squared. And then we go from x squared to x minus 2x, and plus 6 is the constant, plus 1 over x minus 1. And that's it. Very quickly and easily, we've been able to synthetically divide two polynomials to get a resulting polynomial without too much trouble. Now, what happens if, let's say we're doing this kind of synthetic division and we end up with a remainder of 0. Well, all that would mean is there would be no fraction part. We would just, if this had been a remainder of 0, we would have just had 1x squared minus 2x plus 6, and we just stopped right there. No fraction at the end. But since there's a remainder of 1, we have to put that 1 over what we were dividing by. Well, that is it for the synthetic division process. I'm going to add one more problem for you to try on your own, and then we'll do some more practice in class over the next few days. Synthetic division is going to be a big part of your next unit. So we need to practice it now and get good at it so that as we go forward in the course, we are ready for that synthetic division. Okay, so here's what I want you to divide. I want you to divide. This is your try. You try it. You try this one. I want you to divide 2x to the fourth plus 3x squared minus 6 by x minus 2. Put those in parentheses. That is your you try problem for you to try as part of your homework as you're watching the video, and we'll try to talk about this in class. Hope that this is making sense for you. I promise the more you practice synthetic division, you're going to get really good at it over the next several weeks.